And you?
Awesome. So the kids here, they are really excited to hear what you have to say about cataclysmic variable stars. Even I'm excited as well. And
yes,
we are really
too.
thankful for having you with us today. And thank you for accepting our invitation, Mr. Michael.
You're very welcome. I am very proud to be there too.
Awesome. Awesome. All right. So, so Mr. Michael, we basically will have your presentation, and once that's done, and if the students have any questions, they will be allowed to ask questions if that's okay with you. Is that fine?
That's fine. That's fine.
Awesome.
And where
all
are
right,
the
all right, Mr. Michael. Okay,
where are the kids? I don't see the kids. They are there somewhere.
Thank you very much.
Tell me, Sabir, where
are
the kids?
They are here. We got a lot of kids today.
Okay.
Isn't it visible on your side? I think we got a lot of kids today.
Okay, that's good.
Yes, okay.
That's good.
So, all right. Thank you very much, Dr. Michael, for joining. So over to you, Dr. Michael. You can carry on.
Okay, so I will maybe begin with a presentation of myself. Oh, I don't see you anymore. Are you still there?
What's happened? I'm still there.
Okay, good. A short presentation of myself. So I am an engineer in nuclear science, because the nuclear is the way the stars are working. You know that we need that. So that could be maybe a good question for the kids. After that, I make some astrophysical courses, and I worked in majority for the medical care with a nuclear medicine, the nuclear medicine. Okay. So that's for my professional. So no, I am not profession anymore. Okay, I am retired. So that's also good. And my first work, when I worked in an observatory, a very big observatory in Belgium, that was the Royal Observatory of Belgium. That was to count the number of spots on the sun. There are some spots, black spots on the sun. Okay. And I still continue to do that. And doing that, I sketch the sun. So I can maybe explain you after that why I do that and how it is important to do that. Because this is linked with the cataclysmic star. So no, we are on the target. We will explain what cataclysmic stars are based on what we know, because you know that we are not able, like a medicine, to touch the people. We are not able to touch the stars. It's impossible. They are too far. Same the sun is too hot. So the only thing that we receive is the light. And with the light, we can understand a lot of things. So for the cataclysmic star, imagine now that we have a sun, or a star looks like a sun. And around this star, you have planets. But one of those planets is also a star. Jupiter is nearly a star. You know that if we shut down all the light from the sun, all planets disappear because we are not able to see them, but there are still 3% of the light from Jupiter existing. So Jupiter is too small to be a star, but with a lot of more mass, Jupiter could be a star. So that means that you have a star in centrum, which is the sun, and around this star, there is a planet, but also, which is also a star, okay? The fact is that when you have a couple of stars like that, there are gravitation and interaction between the two stars. Sometime, and this is the first type of cataclysmic star, sometime the secondary star is coming very close to the one, and then further, and then close again. Okay? Okay. So that's the first type of cataclysmic star. This is often the case when you have a dwarf main star. And the sun is a dwarf star. You know that maybe. It's very small. The sun is very small. That means that this is very good to know, because a very small star could live a long time. So we have no problem for that. That's for billions of years, the sun will continue to give us the rays. So that's perfect. Sometimes if the star is bigger and bigger, that becomes a giant star. Often those stars are red giant. Red giant stars are more difficult to live a long time. They are like balloon. You see, it's not completely circular. They are like balloon. And if those stars are at the place of Jupiter for the sun, for example, and if those stars are turning around the sun, those stars there is a combination between the hydrogen of those giant red stars and the dwarf star at the middle. This causes a first thing, which is important to know. There are disks. I think I sent you a photo of that watercolor that I did. That's my perception of what it is. And so you can see around the dwarf star a disk which is forming. And the secondary star, the very big one, gives hydrogen to the first one, but this hydrogen stops to the disk. And if the temperature of the disk is high enough, there is a blow up. Okay, so that's the first type of novae. We say novae for a lot of nova. Nova is singular, novae is plural. Okay, so that's the first type of novae. We can know 4 types, but you will see that this type is nearly equal to the third one. So imagine now the disk is heating a lot because the temperature of the dwarf is quite high, and at a certain time, this disk is blow up. This disk blow up in the atmosphere of the star, and that we can see. We can see not the 2 stars. We can see only 1 star, which is the best one, but it's very faint. But when this happens, we have 4,000 or 5,000 more light coming from this couple. So what we see is just a curve with a lot of more brilliance and then going down again slowly. So that's how we can see that. Okay, we can see a very faint star that not interesting, and from one day to the other, 4,000 times, more brilliant than the day before. So that's really a blow up, but not of the star. This is a blow up of the disk turning around the star. We call this disk an accretion disk. That's maybe too big for the kids, but that's an accretion disk. That's the name of this disk. There is a second type of star. When if I remember, because I am not home, you see I am in my car here, and I am not home, so I don't have a lot of material with me to read. But if I remember well, the second type of novae is biggest. So it's 3 times the mass of the sun. So it's not really a dwarf star, it's a common star. But if that happens, and the secondary star, which is a giant red coming very close for the same movement, the mass, the hydrogen mass, is going directly to the star. Okay, if the hydrogen is going directly to the star, that we call a classical nova. So the first was a dwarf nova, the second is a classical nova. And a classical nova, it is the atmosphere of the star which blows up. And that could be 8,000 or 10,000 times more brilliant than the day before. You understand the 2 types of cataclysm that could occur in such a planetary system.
Yes, Mr.
Okay, I continue. You hear me very well? No problem?
Yes, you may.
So you see me, you hear me,
yes,
but maybe you
awesome.
don't understand.
It's very clear.
You understand me too. That's good. Because you know I'm French speaking, it's difficult English for me. Okay, so the third type is recurrent nova.
Yep.
A recurrent nova,
okay.
In fact, it is the same type that the first one. But recurrent, that means that comes and come again and come again. This type of nova is not the fact that you see suddenly one new star in the sky. No, it's the fact that you see on a periodicity, a very well-known periodicity, or sometimes not very well-known, that the disk around the star is blowing up. You see? So, but that occurs maybe in 10 hours, and maybe in 10,000 years. We don't know. That depends on the star. But for example, if I take one of the stars that I study a lot, it is SS Cygnus. It's a very well-known star, very strange star, because the two stars, the dwarf star and the main one, they are nearly connected. You see? So when they are turning, sometimes the red one occults the second one. But anyway, there is a disk also. And this also can occur to make, so this is more a recurrent nova. Because sometimes the star is magnitude 5, for example, and sometimes the star is magnitude 7. And this occurs every 44 days. So it's very easy for you, for example, as an exercise, to show that to your kids, to see this star, which is not too difficult to see. It's in the Milky Way, of course, and it's in the Cygnus. But you can detect this star. It's always visible with a very small material. And then you can see more and more. If you use comparison star, it's easy to sketch the curve of the modification of the light of the star. So that's the third type of nova. And the fourth one, the most impression one, is the supernova.
Yeah.
This is completely different. Nothing to see with the three first. Okay. And this is at the end of the stage of a star. When the star is eating all the hydrogen, they have to eat something else. They find helium then, because the helium comes from hydrogen, from the first fusion. But then after hydrogen, they make the fusion for more and more heavy material, heavy atoms, till the iron. The iron is the last one. And then after a second, less than a second, the star is blowing up. But this is the destruction of the star. Then the star is completely destroyed. So this is a supernova. If this occurs in our galaxy, we will have two stars visible during the daylight. Okay? Two stars during the daylight is not nothing. It's more than the full moon. But so it's now, I think, something like 700 years that we never see a supernova in our galaxy. I detect already maybe 15 supernova, but always in other galaxies. Voilà, that's a kind of resume. I hope not too complex, not too complicated, but I am ready to answer to whatever question you have. If you want, I can continue to that, but I think it's a good resume.
So we'll do like this. Yes, Mr. Michael. So I'm pretty sure the kids might be having questions now on whatever you explained currently. So we'll go with the questions, and then once we are done with the questions, then you can move on to the next part. Is that okay?
Okay.
All right, sure. So we have two students who have raised their hands. So Sudita, what's your question?
How does the supernova happen? What is a cataclysmic star?
I don't understand very well your question. Maybe Sabir, you can help me.
Yeah. So Sudita basically wants to know, like, how does the supernova happen, and what exactly is a cataclysmic star?
So when you look at in the sky, all the sky are the same. They are very fixed. They don't move, and the luminosity of the star are fixed. And suddenly you have a new star in the sky. So you go to the maps, you see in the maps, there is a star on this place, but very faint, not the same luminosity. So that's a new star. Okay, maybe it's not a new star because it's not a new star because the star exists before. So the ancient people call that a nova, which means a new star, but this is not true, it's a fake. The fact is that when this is occurred to the star, we call that a new star, so a nova. And the reason is what I explained before. or it is a dwarf nova with a giant very close, and they eat the dwarf eat the hydrogen or the combustible of the second one, or this is a classical nova without the disk, or this is a recurrent nova making that again and again. Okay.
Right. Okay. Thank you for that, Mr. Michael. I hope you answered Sudita's question. So next we have Binal. Yes, Binal.
Bonjour.
Hello.
In front of a supernova, if there was a red giant, behind the red giant, if there was Earth, what will happen?
I will again ask. Thank you for your
Could
question.
you repeat the question, Binal?
Yes, maybe you can explain me, because I hear you very well, but the kids I don't hear very well.
All right.
In front
Yes,
of
Binal, could you come closer to your microphone if you don't mind, Binal? Yes.
in front of the Earth, there was a supernova. Behind the supernova, there was a red giant. What will happen?
Okay, so your question is there a red giant closer to a supernova? Is that it?
No. In front of the Earth, there is a supernova. Behind the supernova, there is a red giant.
Behind the supernova.
Yeah, a red giant.
All right. Okay. So, Mr. Michael, so the question Binal wants to know is that is there a red giant usually behind a supernova?
It's a good question. I will say no. Yes and no.
Okay.
Indeed, a red giant is a very big star, more big than all the solar system, very big star. Okay. And when a star is very big, it is difficult for the star to have a let's say, quality of, how can I say that? The movement of the star itself is moving. So the star is not a perfect balloon like you see the sun. It's a balloon who makes that, okay? So because of that, those stars are not living a long time. But what you are right, it's on a certain time, those stars, the giant, mainly the giant star, but not only, but mainly the giant star, are not blowing, but they are collapsed a lot to become very, very small star, and then they blow up or not. Or they blow up completely to become a supernova, but they can also becoming a black hole, they can become a pulsar, a quasar, and so on. You see, that depends of the mass, the initial mass of the star. But it's a good question. Good guy.
Thank you for that, Mr. Michael. I hope you answered Binal's question. Is that okay, Binal?
Thank you, Dr. Michael. I got the answer.
You're
right.
very
Okay. Next, we
got
got Arudit. Hello, Arudit. You got a question?
Yes.
Yes, Arudit. What's your question?
Two supernovas happen close to each other at the same time?
Could you repeat that again, Arudit?
If two supernovas, what will happen if two supernovas happen at the same time near each other?
Oh, okay. So, Mr. Michael, Arudit wants to know what if two supernovas happen close to each other at the same time?
Huh. I don't think it is, well, it is possible. It is possible because some galaxies are very well known to make a lot of supernova. Okay, when I say a lot of supernova, that means one every 20 years. So two on the same time, that could be very, very interesting, because imagine you have two new stars, two new sun in your up your head. That could be incredible. So I never saw that, and I don't think that in the history someone saw two supernova on the same time in the same galaxy. What I saw is two novae. Two novae, yes, that's possible. Two novae on the same time in our galaxy, it's possible. But two supernova in different galaxy, maybe, but not on the same time. No, not yet, not yet. You have to discover that.
All right. but there is still a possibility, right?
Oh, yeah, yes, it's not impossible. It's not impossible. It's a question of
Okay.
statistic.
All right, thank you. I see. Okay. Yes, Ayusha, what's your question?
Excuse me, sir. In which explosion would be the most powerful, a supernova explosion or a red giant explosion?
Sorry, can you repeat again?
Which explosion could be powerful, a red giant explosion or a red giant explosion and a red giant explosion and
Could you come a bit more closer, Ayusha? Because it's the same with Binal, so I could not understand because your microphone is a bit far away.
which explosion could damage a lot, a red giant explosion or a
Sorry, yes, Ayusha?
a red giant explosion or a GammaRay explosion, sir? I mean a star explosion.
Okay, so you want to know if there's an supernova explosion, that whether it releases gamma ray.
Yes.
Is that your question? Okay. So Mr. Michael, so Ayusha wants to know, like, when there's a supernova explosion, does gamma ray is emitted from it?
That's incredible.
Is there a gamma ray burst?
It's an incredible question. Yes, indeed. That's very strange that I heard that from a kid. But when a supernova blows up, that makes a lot of things. Gamma ray, it's a possibility. That's sure, because it's a real cataclysm for the star. The star is blowing up completely. There is nothing stay. Okay, so you have to understand that when I say at the beginning, when the sun is burning hydrogen and then helium, if you continue to the Mendeleev's table, which is maybe too complex for them, but to more heavy material, we stop to the iron. So that means that on Earth, on our planet, it's impossible to find gold or silver. It's completely impossible. The only way, because we know that there is gold on our planet and there is silver and heavier material, the only way to make that, it's a supernova. When a supernova is very powerful, blows up completely, the fusion of very heavy material could occur. And that we find on the planet around, first on dust and then on planet making around the sun. So on Earth, we know that there are a lot of supernovae blowing up in the vicinity of our planet or of our solar system. And when the sun is born, okay, they eat those dust, those small stone, those heavy metals to make our planet, for example. So that's very powerful. But indeed, you can also have X-ray, gamma ray, and photon ray. That means the light. The light is very powerful then. Good question.
So I have another question. Is a red giant explosion more powerful than a supernova explosion?
Something you mean?
So the question.
Yeah.
So the question Ayusha wants to know is that is a red giant explosion more powerful than a supernova?
It is the same, huh? It is the same, because a supergiant becomes a supernova. Something more powerful could be a blazar, for example. It is difficult to explain, or the fusion of two galaxies or two black holes going together. That's more powerful. That's also a big cataclysm, but that's not cataclysmic stars. That's completely different. Those are not stars. That's not the subject of today.
Yeah. All right. Thank you for that, Mr. Michael. Last, I think we have Imalka. Yes, Imalka.
Okay. How strong is a cataclysmic star?
That's a short question, but could you help me, Sabir?
So he wants to know how strong is a cataclysmic star.
Oh, strong.
Yep.
Imagine we are on Earth and Jupiter is another star. And when Jupiter comes very close to the star, every, for example, 200 years, the sun eats a part of the hydrogen of Jupiter because it is a star. Then you will have much more light coming from the sun, but a lot of more, 4,000, 5,000 more. Imagine the temperature that you have maybe in your island now or here in Norway. The temperature must be 1,000 Celsius. That's impossible to live on such a planet. So I think that effectively, if you have a very big cataclysm like that on a double system with 2 stars, the planets are not viable. So we are very lucky to be on a very small planet turning around a star, which is very slowly variable, not too much, just as we have, and that all the planets are not active.
I see. Okay. Thank you for that, Mr. Michael. Adisha?
If there are happening supernova explosions in our galaxy,
So is there any supernova explosions in our galaxy? The Milky Way.
Yes, so 700 years ago, there is a Danish observer, Tycho Brahe, we call that. He have a very big crater on the moon with his name. And when he was alive, he say that he see a supernova, but it was alone. So normally, scientifically speaking, if someone sees something alone, it's not sure. It may be a fake news. We don't know. We are not sure. However, when he say that, he write that on a paper, and we look in the sky where he say that the supernova exists, and now we can see indeed a remnant, so some dust at this place. The most well-known is the one discovered in the year 2033, I think. I'm not sure about the date. I was not born. And a Chinese observer observed supernova. That's the second in the history before. And on this place, you have the Crab Nebula now. And the Crab Nebula is expanding. So we know that the Chinese observer are make a very good job. So we know exactly where this supernova was. And on this place, we see now today a bulb of dust, which is increasing. So if we ask to a model, for example, to go back in the past, it is true that it was a supernova. So maybe the question that I heard is different. It's maybe more complex, saying, do we have the possibility to have another supernova in our galaxy now? There are some good candidates for that. Betelgeuse, for example. You know, Betelgeuse is the second is Alpha Orionis in the constellation of Orion. If you see this constellation of Orion during the night, you will see that there is a star very red. That's a giant red star. And last year, 2 years ago, this star makes a different light than before. So this is a good candidate to be a supernova. There is another one, Aldebaran. Aldebaran also could be a good candidate too. Those 2 stars are quite brilliant, very red. When you see that in the sky, you see it's not blue, it's not white like the other, it's more red. So you can make this test and make the comparison between Orion and the other star of the same brilliance. And you will see that there are some movement. So those are candidates, but when? It's impossible to say, impossible to say. We need young people like you to find the solution to know where, when, and where the next supernova will blow up in our galaxy.
Okay. Thank you for that, Mr. Michael. So I think that's all questions that we have for now. You can carry
Okay.
on with the other part. The next.
Okay. And what is the next for me?
Yes.
Normally, I was just speaking about cataclysmic star, but now I can speak about the sun.
Yes, sure.
That's that. I don't make mistake.
Sorry?
I don't make mistake. It is what you are waiting for.
Yes. So we were about to move to the second part, right, of your explanation, and then we had few kids who wanted to ask a question. So now
Okay.
you can carry on with the part.
Okay, so now I will show you something a little bit different and maybe more funny. I go out of the car, and you see, you know that I am in Norway. And look here at my telescope. So I have a small car. You see on the car, it's written bed and telescope. There is bed, telescope, and a wife on board. And this is the telescope that I use to see every day the sun. I use a very special filter to do that. I don't know if you see that. I use a very special filter because otherwise you are blind directly. So take care. Never ask a kid to look at the sun. It's very dangerous. Never do that. And also there is a second thing that is interesting to see here. I don't know if you see here. I am nearly at 70 on the 70th parallel. So I am very close to the North Pole here. It's why this axis is nearly horizontal because the Polaris is on this direction, very close to the zenith. You see? So that's the material I use every day to make something like that. So I have a book here. I do that from my home too. But when I am on the way also, I have such a job to do. Voilà. This is the sun today. You see it? It's okay?
Yeah.
And every day I sketch the sun. Every day. You see that there are a lot of spots on the sun here. Today,
Yes.
only two groups. And there are days with a lot more. So that means that the sun is not a cataclysmic star, but it's a variable star. You see all the sketch I do. I do that not alone. We are something like 40. When the summer is there, we are 80 to sketch the sun on paper every day when it is possible. And we do that since Galileo. Galileo was the first to do that. And since Galileo, we have the possibility to understand the variability of the sun because there are people doing tough stuff like that. Okay?
Okay.
So this is a job made by professional or by, no, I am not professional anymore. I am amateur, but I continue. I like to do that. And so you see, that's something very important because when you say, if you say no, that the photo, to make a photo of that is more important, it is possible that the photo will be more accurate, but you lose the historical way of sketching the sun since Galileo. So there are 3 professional observatories in the world. I think one in the USA, one in Switzerland, and one in Belgium, where people are paid to sketch the sun every day. So that is very important. So I'm working with them. So also that's something that I can maybe share with Wendy after the session here. So I show you that because we know today we know that the sun is a dwarf star, variable star, and electric star. Electric, that means that there is magnetism inside the sun. That's maybe more complex to explain that to the kids, but I am open to do that, but maybe with my material from home, because I have a lot of material for kids to explain how the sun is working really. Why are those spots? What does that means? Is that important? Is that dangerous? No, it is not dangerous. Be sure. Okay.
All right.
So
Okay.
that's what I want to share with you now. So you see the material is not very complicated, but it is very dangerous for the eyes. So don't let the kids looking at the sun without a professional filter. That's not a good idea.
Sure.
When Galileo died, he was blind. You know, Galileo does not know that there are infrared and ultraviolet ray from the sun. He does not know that. So he was dead, blind. That's not good for an astronomer. Not a good idea.
All right, then. Thank you very much for today's session, Mr. Michael. It was very interesting, and the students enjoyed as well. They asked a lot of questions, and I learned a lot from your explanation and your presentation. It was really good. So before I let you go, I do have your sketch that you shared with us. Let's share it on screen so that everyone could see. So this is the sketch that Mr. Michael shared with us. So is this visible to everyone?
Yes, sir.
Yes. So this is the sketch.
So you see on the middle, very brilliant, on the middle, the very brilliant one, that is the dwarf, looks like a sun. Very close to the sun, there is a disk. And on the opposite place, there is a giant red. And you see a line coming from the giant red to the disk, turning around the dwarf one. And this is not very blowing up, no, but after a certain time, the disk is blow up. So that's my perception of what it is. Huh? It's just an artist sketch. This artist sketch is not made when I look at a star. It's impossible. We are very too far from the star to have the idea of this sketch. It's just because of the modelization of the calculation that we made that we can detect that this must be something like that.
All right. Okay. Thank you for that, Mr. Michael. And we would also like to tell you that we do have a physics camp as well for our students. And it's very interesting to have you explain about this stuff. So I'm looking forward to have you in our physics camp, if that's okay with you in the upcoming weeks. We would love to hear more about certain topics. We could fix a topic and we could have a lecture on those as well. Is that okay with you, Mr. Michael?
Yeah, it's okay. So don't hesitate to invite me. But sometime, like yesterday, on the site where I was, there is no network.
All right. Okay. So we will
that depends when I
do that. Sure. Sure. All right.
Thank
you very much.
That will be much more easy when I was home again. That was in September. Okay.
All right.
So
okay.
As from September, no problem. It is much more easy for me. And also I have a lot of material. I also have to share that with Wendy, maybe. I have some idea for the kids because I have today in France, I have something like 20 kids that I follow. Okay. Also very young ones and more. And some of them are today, the first one is astrophysician. No, today, since 2 weeks. So that's a success for her. That's very good. And some of them are making study in astrophysics too. So I like to do that. I do that in French, of course, but I can maybe share some idea to do that with Wendy, maybe, because it's my contact in AAVSO.
All right. Okay. Thank you very much for accepting today's invitation, Mr. Michael. And for sure, Miss Wendy will be in touch with you, and she will contact you if there's anything, or if you are planning on having any webinar anytime soon. So Miss Wendy will be in charge of that. And I would like to take this opportunity to thank Miss Wendy again for organizing this webinar and giving our kids a really good opportunity and a good exposure on topics that are very rarely discussed when it comes to cataclysmic stars. So thank you very much for joining, Mr. Michael. I hope to see you again in the upcoming sessions. Thank you very much.
Okay, thank you. Thanks a lot. And bye-bye to everybody. Bye.
Take care.
Thank you, Mr. Michael. Thank you,
You-
Mr. Michael. Bye.
Thank you for you.
Bye.
Bye-bye.
Mr. Michael.